Hi there, this is Marcus King. This is the first in a series of screencasts we're going to do on implementing common aspects using PostSharp. For those of you who are unfamiliar with the concept of aspect-oriented programming, AOP, or PostSharp, I recommend going out to the SharpCrafters website at www.sharpcrafters.com and spend a little bit of time familiarizing yourself with the product and the documentation, which is actually pretty good. If we go under documentation and drill down into examples, we'll see the basis for this series of screencasts, where we have real-world implementations on how to do common aspects. The one we're going to concentrate on today is exception handling, or as they call it, exception monitoring. Let's get into the project. I think it's important to spend a little bit of time familiarizing you with the layout of the solution. I try to model it as close as possible to a real-world application while still maintaining simplicity. As such, it's a layered application which consists of a common layer, which is shared between all the different layers of the application. It includes our entities or models, things such as an abstract bank account, the concrete implementation of a checking and savings account, an employee, and roles that the employee can belong to. This library also includes exceptions that are unique to this application, as well as a utility folder which houses things such as logging and caching. In this case, we're just going to concentrate on caching. We also have a data access library, which houses our bank account repository. This is a fairly simple version of a repository and doesn't connect to a backing store such as a traditional database. Everything is just housed in memory. I don't recommend this for a real production application, but it should suffice for our example. And then we have the heart of the application, which is our services project. This houses all of the business logic. In our banking service, we have all the things that you would expect. We have get account, credit an account, debit an account, and transfer between two accounts. Commonly, when we're in applications and we need to handle exceptions, I think we can simplify it that pretty much all we do usually is just write out some sort of trace or log message and then let the application persist. So let's go ahead and do that. We'll modify our credit method and have it throw a new application exception. So that'll be the first thing that happens. Now, Microsoft doesn't recommend throwing types of application exception, but it should be okay for this presentation. THROW. Okay, now in order to implement an aspect that would handle this exception, we'll go into our common project and we'll create a folder called aspects. You could also call this advices. I'm putting it under the common project because it really fits well with the whole idea behind aspect-oriented programming, which is creating reusable modules that'll be used throughout all the different layers of the application. So we'll go into our aspects folder and we'll create a new class and we'll call this handle exception attribute, because we're going to use this like we would an attribute. And part of the .NET framework requires that whenever we call a class that we intend to be an attribute, we have to end the name in the word attribute. So let's go ahead and create it. Okay, so our class is created. We need to go in here and modify this a bit. So we'll make it public, and we'll make it serializable, which is a requirement for using PostSharp. Refer back to the SharpCrafters website for why. And we need this to derive from the onException aspect. EXCEPTION. And we'll go ahead and add a reference. Now we want to handle when an exception is thrown. So in order to do that, we'll do override. So we're going to be overriding a method from the base class of onException aspect. And the one we're going to get is onException. Okay, so before we said that pretty much all we're going to do is either log or write some sort of tracing statement to let us know that the exception occurred. So let's go ahead and do that. So we'll say trace dot, and we'll go ahead and add the reference to that in system diagnostics. So trace dot write line, and we'll say exception handled, and we'll put out the message from the exception. So we do args.exception.message. Now, one of the neat things about handling exceptions is that in this parameter here, method execution args, we have access to the exception that was thrown, but we also have access to the method that threw the exception. And this is the method base that you would see whenever you're using reflection in .NET. Okay, so you would think that this would be enough to handle it, but what we actually want to do is we want to do args.flowBehavior equals flowBehavior.continue. And what we're telling the aspect is once we have this logged, we don't want to let the exception bubble up. We want it to just move on. Because what would happen is this would throw an exception, and when we go in here to say that we wanted to use handle exception, it would handle the exception by writing a trace statement, and if we didn't put anything, it would actually rethrow the exception. So that's why we go ahead and add a flow behavior of continue, which just acts as if the exception never occurred and exits the method. So now that we've got that all set up, let's go ahead and set a breakpoint and we'll run the application. So F5. Now if we look at our stack trace, we should see that from here the exception was thrown in the credit method, which is what we would expect. That's where we threw it from. Okay, so we're getting ready to write out the exception message to the console screen. Keep in mind this is a console application. You certainly could do this in a web app or WinForms app, but this was the simplest thing for the means of this presentation. And we'll go ahead and let it step down, step over. So flow behavior continue. Now the next thing that will happen is it just acts like nothing ever happened. It threw the exception and the method exited. So if we go and view our console output, we'll see exception handled, error in the application. This is the default message for application exceptions. Okay, so that's good and well, but it's really kind of simple. Let's modify this a little bit to do something interesting. Let's say we only wanted to handle certain types of exceptions, right? So what we can do is we'll go in here and we'll create a constructor. So do public handle exception attribute, and we'll take in a type, and it'll be expected type. So this will be the type of exception that we expect to be thrown, and the one that we will require to be present for us to do anything useful with it. So we'll go ahead in here and create a private variable of type, and we'll call it expected exception, and we'll set it. So we'll do expected exception equals expected exception type. Now one of the neat things about PostSharp is that we can pass in any of the parameters that we need to control our logic and our aspect in via the constructor. And we're going to do just that. So if we go and override the getExceptionType method, all we need to do is return the type of exception that we expect to be thrown. In this case, expected exception. Now we go back over to our banking service, and we'll notice that the handle exception attribute is underlined. That's because we have a compiler error. Because we don't have a default constructor anymore, we have to pass in the type of exception that we expect to be handled. In this type, application exception. So if we go back here and we set a breakpoint on the onException method, and we run the application, it should behave just as you expect. So we notice that the breakpoint was hit, the item is traced out, and the flow behavior continues, and we get the same exception message that we got before. Exception handled, error in the application. So let's see what happens when the type of exception that we expect isn't the type that is thrown. So we'll change this from type of application exception to divide by zero exception. We'll go back here and we'll set an additional breakpoint. We'll run the application and we'll see what happens. Things are going to behave a little bit differently this time. And as we see, the application exception was thrown and unhandled. We'll notice that neither of these breakpoints were hit. That's because PostSharp does a really good job of handling this
for us. At build time, it actually takes the expected exception type, calls it, and makes sure that the type that was thrown from the method matches the expected exception. So it never enters into our handle exception attribute. So that's pretty useful, right? We can use this in scenarios. Let's say if we have a web services layer and we want to catch only types of SOAP exceptions, we can use something like this pretty easily. Now, one of the other interesting things we can do with exceptions is that we can say what type of exceptions we expect to be thrown, but what if we want to wrap it in a certain exception type? So let's do that. Let's go down here and we'll create a new constructor. We'll say public handle exception attribute, and we'll take in type of expected exception type, and we'll take in another type and we'll say wrap in exception type. We'll go up here and copy this line because it should be exactly the same, and we'll need to create a new member variable, and we'll call it wrap in exception. And so we'll set it wrap in exception equals wrap in exception type. Now keep in mind, we're already overriding the get exception type, which handles the case of making sure that the exception type was thrown matches the type that we expect. Now we need to handle when we want to wrap the exception. So if we go down here and we say exception, which is the base of all exceptions, and we'll say new exception equals, and we're going to cast it to an exception, and we're going to say activator dot create instance of the type of wrap in exception. And now we need to pass in the parameters for the constructor. So in this case, we'll create a new object array, and the parameters will be the message. So we'll say wrapped, and we'll pass in the inner exception. In this case, it'll be args.exception. And then all we need to do is throw new exception. So we've got the aspect handling taking a certain exception type, wrapping it in a new exception. So let's go back to our banking service. And first we'll need to change the type of exception that we expect to be thrown from a divide by zero exception back to an application exception. And then the type we want it to be wrapped in, we'll say type of, and in this case we'll use banking exception, which is a custom type just for this application. Let's go take a look at it. It's actually a pretty simple implementation. It doesn't do much. It just takes in a message and an inner exception type, and then sets those to the base of the exception type, which it extends. So let's go make sure our breakpoints are set, and we'll run the application. So we're getting ready to trace it out. We're setting our flow behavior, creating a new exception type, which is a banking exception, and then we're going to throw the exception. And just as we expected, banking exception was thrown. Now this is useful in scenarios if we go back to our web services layer, where if we want to handle certain types of SOAP exceptions and wrap them in exceptions that are unique to our application, we can do so with just applying an attribute. So it's very powerful. I hope that this was useful in demonstrating the power that PostSharp has in taking a lot of the common scenarios that we have in programming and making our lives easier. Stay tuned for future screencasts and be sure to check out sharpcrafters.com for more information.